Hi, we're going to start today with looking at how to find the volume of what we call an irregular solid. So you can see we have a rock here that's not a liquid, so we can't just pour it into a graduated cylinder to find its volume. And we can't use length times width times height because, as you can see, it's not consistent. It has one width there and a larger width there. So what we have to do is use a procedure called water displacement. And a few years ago, somebody called this water push out of placement. And I think that's pretty good. We'll go ahead and start with this picture. The first thing that we need to do is we need to start with some water in a graduated cylinder. It doesn't need to be to any particular point, but I will just call this the initial graduated cylinder, and then which will be the first one, and then this will be our second one with the object actually in it. So basically we're going to take the volume of the liquid in cylinder 1, volume 1, and the difference between that and volume of the cylinder with the object in it, which I'll call volume 2, and I'll put that first because that's going to be a bigger volume, and we're going to subtract and get the difference. Now the difference will be in milliliters, but our object is solid, and solid volume is in cubic centimeters. So we're going to have to change milliliters to cubic centimeters. Now luckily, at the beginning of the creation of the metric system, it was created such that 1 milliliter of water occupies 1 cubic centimeter of space or volume, which makes it a 1-to-1 relationship. So if this solid object pushes 5 milliliters of liquid out of place, then it would have a volume of 5 cubic centimeters. So let's take a look with our sample. And the first thing that we need to do to find the volume is to look at the scale. So I'll pick a numbered line to the next numbered line and look at the difference between 20 and 30. The difference is 10. That value is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intervals. 10 divided by 10 is 1, so the scale of this graduated cylinder is 1 milliliter. So now we can find the level of the liquid. Here's 20, 21, 22, 23, 24, 25, 26, 27, 28. So our V1, our volume 1, is 28 milliliters. Now, after we slide the object down into the graduated cylinder, the water comes up. Here's our 30 line, 31, 32, 33. So now the water level is 33. That object has pushed out of place, displaced, 5 milliliters of liquid. However, a solid object, we don't report its volume in milliliters, so we have to change it to cubic centimeters. So, if the object pushes out 5 milliliters of liquid, and we have this relationship for every 1 milliliter takes up the same room as 1 cubic centimeter, then if I have 5 milliliters, that would take up the same volume as 5 cubic centimeters. So this object must have a volume of 5 cubic centimeters. All right, I have another example right up here. Let me change colors, and we'll set this up to see if you can do it. So we first put water in a graduated cylinder. I'll call that reading 1. Then we slide the object into the cylinder. I'll call that reading 2. So we take the volume of the cylinder with just the liquid, and then we slide the object in and take the volume with the object in it, take the difference, and get how many milliliters of water have been pushed out of place. Then what we need to do is equivalent or equal how many cubic centimeters. Now you also have to remember to convert milliliters to cubic centimeters that every 1 milliliter takes up the same amount of space as 1 cubic centimeter. Alright, go ahead and pause the video and see how you do. Alright, let's compare our answers. First of all, I'm going to start with taking the volume of just the water. And so I'm going to go from one numbered line to the next. The difference between 200 and 100 is 100. And that is divided into 1, 2, 3, 4, 5 intervals. So 100 divided by 5 is 20. So the scale is 20 milliliters. Every distance from line to line is 20. So our initial water level, luckily enough, is right at 200 milliliters. Now, once the object slides in there, the water level comes up. So we have 200, 220, 240, 260. It's a little bit more. I'm just going to call that 260 for our demonstration. So the difference is 60 milliliters. So the solid object pushed out of place 60 milliliters of water. But because it's solid, we can't leave our object with the volume of liquid measurement. So for every 1 milliliter, we have 1 cubic centimeter. So since we have 60 milliliters, that would equal 60 cubic centimeters of volume. So our answer would be that the object occupies 60 cubic centimeters of space. I hope you got that right. Know that you can watch this video over as many times as you need, or you can come and see me and we can do some more examples. Good luck and have fun.